basics when it comes to this unit. Okay. First things first. Okay. Clean this up here. I don't like it. Much prettier. Okay. So the first thing I want to talk about is we are going to change the way we look at angles. Now, when we measure distances in Canada, we measure them either in kilometers or in miles. We measure things in centimeters or inches. So we have basically two types of ways in which we measure. We are going to learn a second measurement for angles. Okay, now it's somewhat off on the theory part of this, but you'll get a better understanding of it when I explain it. So, number of degrees around a circle is what? 360 degrees. All circles are 360 degrees. That's pretty simple, pretty straightforward. Now, if I ask you to find the distance around the circle, that's called the circumference. And we find the circumference by going 2 pi r. So that's the circumference of the circle. Now, we are going to deal with what's called the unit circle. And the unit circle means that the radius of this circle is going to be 1. So the distance from the center to right here to anywhere on the circle, that distance is going to be 1. So that means then that the distance around the circle is 2 pi. Now, when we talk about the portion of the circle or the distance around the circle, we're going to work in what we call radians. Well, this is a measure in radians, 2 pi radians. Now, on your calculator, you have degrees, radians, gradients. We never use gradients. We only use degrees and radians. And what radians does is it converts it to a portion of the distance around the circle. So 2 pi is equivalent to 360 degrees around the circle. Therefore, what would 1 pi be equivalent to? 180. Awesome. Okay. This is your most important ratio that we have to deal with. Pi equals 180 degrees. We are going to use that ratio to convert other angles to radian measure, which is a portion of the distance around the circle. So, for example, to begin with, I'm going to take an angle measure of 30 degrees, but I want to know what its radians are. That's the distance from here to here. So to do that, I simply take 30 degrees and I multiply it by that ratio, pi over 180 degrees. So pi radians over 180 degrees. Now, if at all costs or at all possibilities, I'm going to leave pi as part of the answer. So that becomes 30 pi over 180. But I want to reduce the fraction. What's 30 over 180 reduced?
Pi over 6.
Wicked. Great job. Good start. Pi over 6 radians. So 30 degrees is equivalent to pi over 6 radians. Okay? The distance from here to here in degrees is what? How much? 90 degrees. So I take 90 degrees and I times it by pi over 180 degrees. How many radians is that? Reduce the fraction. pi over 2. Well done. So 90 degrees is pi over 2 radians. So to begin with, all we need to do is we need to be able to convert from degrees to radians. So let's find out what 3 pi over 4 radians is in degrees. So to do that, when I stacked it here, I wanted the radians, so I had to divide by the degrees. Here, I want the degrees, so I have to divide by the radians. So I change that up. I multiply by the reverse of the reciprocal of that. Okay? So now, when looking at this, right here, as I've written it, I've got 3 pi times 180 divided by 4 pi. So the pi's cancel out. Now I need 3/4 of 180. Anybody know what 3/4 of 180 is? (135 degrees). Okay? Now, all right, so 135 degrees. This right here I call my terminal arm. My terminal arm always starts on the positive x-axis. And when I have a positive angle, I rotate it counterclockwise to get to the angle. So I'm going to rotate this. If I want 135 degrees, to right there is 90. That angle right there is 135 degrees. So just remember that. When I go on a positive angle, I rotate it from the x-axis counterclockwise. Okay? So that angle right here would be 135 degrees. So that's the start of it. Now, pi is a value, but we try not to work with irrational numbers if we can help it, because pi is an irrational number. But it can be done that way. So we could change pi over 6 radians to an actual value. So take your calculator right now and take pi and divide it by 6. So we find out how many radians that is. What is it? What's pi divided by 6?
0.5235.
Okay, so there. 0.5236 radians. Okay, so what you'll see on page 205 is it says estimate each value of each radian measure in degrees. So it gives you the radian measure as a value like 1.4. So to change it to degrees, I put the degrees on top and the radians on the bottom, like that. So take your calculator right now, go 1.4 times 180, divide it by pi. What do you get?
I got 80.214.
Perfect. And I like that you gave it to me in 3 decimal places. That's it. It's not very complicated. All you're doing is timesing by pi over 180 if you want to change from degrees to radians, or you times it by 180 over pi if you want to change from radians to degrees. That's all there is to that first section. Okay? Now, I'm going to get into this next part. This is the part that has a lot to it, but we gotta crush it quickly. And that is this. All right. We're going to look at 2 different graphs. The first graph we are going to look at is y equals sine x. So a trig graph. Now there's 5 key points for this. And I'm going to use this circle. So I'm going to explain, actually I'm going to do this one better. Again, I have to try and do this. I would love to give you a much greater day on this, but we don't have the time to do it. So we've got to get this done as quickly as we can. All right, so, okay, the first thing I want to do is I want to look at, I got to do this. All right, we're working with the unit circle. That means the radius is a value of 1. Okay, so everywhere around the circle, the radius is 1. What does that make this as a coordinate right here?
1, 0.
Yeah, beautiful. Okay, 1 and 0. How about right here?
0, 1.
Okay, over here. Excellent. And down here?
0, negative.
Okay. First things first. Now, I'm going to help use this to help explain the graph of sine x and cos x. Okay. Now, I'm going to pick a coordinate. That coordinate right there, I don't know what the coordinate is, so I'm going to make it x and y. We okay with that? So I just picked a coordinate on the circle and make it x and y. Now I'm going to draw a line right here, like that. And I'm going to put theta down here. So I don't know what that angle is either. So I'm going to use some trigonometry here. I'm going to draw this down like this, and I'm going to create a right angle. Okay. What is the distance from this spot right here to that spot right there? What's that distance? The distance from right here to right here. No? There you go. X. So what's the distance from right here to right here? Y. Okay. And the distance from right here to right here is what? 1. Awesome. Okay, we're rolling here. Love it. Okay. So, if I'm looking at the sine of theta, what is the value of sine theta? I got a right triangle here. Right angle trig. Opposite over hypotenuse. What does sine theta equal on that triangle? Y over 1. What about cos theta? Adjacent over hypotenuse. Simple, right? Good so far? Just using right angle trig. If I wanted to know tan x or tan theta, what would tan theta be? Y over x. Right on. Okay. Now, this one I'm going to not do much with. But the whole point of this is this. If I am talking about any coordinate along this circle, the x value is going to be equal to the cos theta ratio. The y value is going to equal the sine theta ratio. Now, I'll explain why it's important in a second. But every coordinate on the circle, on this circle right here, the cos value is going to be the x of the coordinate, and the sine value is going to be the y ratio of that coordinate. So if that's the case, and my angle going from here to right here is 0 degrees, what is the cos value of 0 degrees? What's the x value on that coordinate? 1. So the cos of 0 degrees, punch into your calculator right now. Cos 0 degrees is equal to 1. The sine of 0 degrees is therefore then equal to what? 0. All right. What is the cos of 90 degrees equal to? And what is the sine of 90 degrees equal to? 1. What is the cos of 180 degrees equal to? What is it? -1. What is the sine of 180 degrees? 0. So each of these coordinates here, the x value represents the cos value, and the y value represents the sine value. So that's important. Okay? Now, here's what's going to happen. If I were to graph this now, so I want to draw a picture of that. At 0 degrees, what's the sine value at 0 degrees? Yes? No, you got it right the first time. Don't change your mind. It's 0. It's right there. So I mark that on my graph here. 0. Actually, I need green. Okay. At 90 degrees, what's the sine value? 1. So it goes right here. At 180 degrees, what's the sine value? 0. At 270 degrees, what's the sine value? -1. And at 360 degrees, what is the sine value? Great job. Well done, Laura. Okay? All she did was follow the y value around the circle. 90, 180, 270, 360. That's how I get that graph. Okay? Now I'm going to do the cos and go around the circle. So now I'm looking at the x value of all of them around the circle. So what is the x value at 0 degrees? 1. It starts up here. At 90 degrees, 0. At 180, -1. At 270, what's the x value? And at 360, what's the x value? 1. Okay. All right, there we go. I have created 2 periodic graphs. The first one is y equals sine x. The second one is y equals cos x. Okay? They're periodic because they repeat. That keeps going forever and ever. So have a look here. This is what this is going to look like. Now I'm going to have to play with it a bit to make this work. Go here, kill that. Y equals function sine. Excellent. X. Close bracket. Hey, that even worked in better than I thought it would. Awesome. There's a graph of y equals sine x. It goes forever. Now, it just so happens that these measurements right here are in radian measure and not degrees. So this point right here, this peak point, is at pi over 2 and 1. Because that's 90 degrees. This point right here, pi and 0. This point right here, 3 pi over 2 and -1. That one, 5 pi over 2 and 1, which makes no sense. Oh, I missed one here. That's why. Right there. 2 pi and 0 and 0 and 0. Okay. The first value of each of these coordinates is the x value along this axis here. It is a measure value as an angle. So I did it by using degrees. 90. So this coordinate right here. So let's do this one. This coordinate right here, 0 and 0. This coordinate right here is 90 and 1, 180 and 0, 270 degrees and negative 1 down there, and 360 degrees and 0. They used 90 is pi over 2, pi, 3 pi over 2, and 2 pi. Okay? A lot here. There's a lot more coming. All right? Okay. Now, that is how I get this. I don't need this anymore. I needed that to show you how to get here. Now I got to spend time on this graph, on these two graphs right here. Find out all of the pieces of information on them. So it starts like this. Okay. All right. So I got it here. So in all of these sine graphs, I have 5 key points. So again, this is 0 and 0. This is 90 degrees and 1, 180 degrees and 0, 270 degrees, negative 1, 360 degrees, and 0. So it's easier for us to use degree measures, but when we do regression, we have to use radians. So we'll get to that. But here's the first thing that we need to know. Write this down. Amplitude. The amplitude is the maximum distance from the equilibrium position, from the midline. The maximum distance from the midline or the equilibrium position. That is the distance from this line right here to right there. That is your amplitude. Your amplitude in this graph is 1. It's just the distance from the equilibrium position or the midline position. The midline is the line that divides it in the half. In that case, that line is y equals 0. Okay? So there's the first thing. The graphs 2 periodic functions on the following characteristics. All right. There is, because this, I'm going to draw an arrowhead here and an arrowhead here. That means that they go on forever. Left and right forever. What does that make the domain for this graph then? They go left forever and right forever. What's the domain for that graph? Yeah, thank you. X is an element of all real numbers. It goes left forever, right forever. All the periodic functions do. Okay? We are only working with sine and cos in this class. We don't touch tan. What is the range for this graph? How low does it go? Negative 1. How high does it go? 1. Your range is negative 1 to 1. How many x-intercepts are there on that graph? How many do you see on that one? X-intercepts. 3. But the graph goes forever left and right, so there's an infinite number of x-intercepts. Okay? And then this graph, where do you see them occurring? Every how often? Every 180. Yeah. Awesome. Great work. 0, 180, 360. The next one will be 540. Next one will be 720. Negative 180. Negative 360. So that's x-intercepts. Okay. We have an amplitude of 1. Our period. Again, new to you. Change the color so you understand that this is new to you. Our period is, when does it repeat itself? When does this graph start repeating itself? After how much? What's the timeline? When does it repeat itself? After how many degrees? Excellent. The period for this graph is 360 degrees, or how many radians is that? How many radians was 360 degrees?
2 pi.
Right on. 2 pi. Very good. Okay. A midline defined by the equation y equals 0. The midline is the horizontal line halfway between the maximum and minimum values. The two graphs oscillate about this line. The midline in this case is this axis, y equals 0. That's your midline. It divides it into two equal parts. Crest, trough, whatever. Maximum, minimum. Halfway in between is your midline. And that's about it for that. Now, okay, one last thing which isn't very difficult, and that is, how do you find the equation of the midline? How do you find the amplitude? And how do you find the period? Those three things. We've got to figure those out. So look at page 210 now. The midline, again, new to you, can be found. It's an equation, y equals. And it can be found by taking the maximum value, add the minimum value, divide by 2. You average the maximum and the minimum value. That's how you get the midline. How you get the amplitude you can take the maximum value minus the midline value. That's one way to do it. You can take the midline value minus the minimum value. That's one way to do it. You could take half the distance from the maximum to the minimum. Another way to do it. Okay? The period is the one that is a little bit, yeah, go ahead.
Oh, wait, no, never mind.
Okay. The period is the one that we have to figure out. If the graph is given in degree measure, you find the period by taking 360 and dividing it by the b value, which is going to be difficult right now to explain. But the other way to find the period is pick 2 points in similar position on the graph and subtract them. So I'll show you that right away. That's the easy way to do it. Okay? All right. On page 210, they give us a graph. The graph is of a sinusoidal function. Describe this graph by determining its range, the equation of its midline, its amplitude, and its period. All right. First things first. What's the range of that graph? What's the lowest it hits? -4. How high does it hit? 8. The range for that graph -4 less than or equal to y less than or equal to 8. -4 to 8. Rats. Okay, first things first. Anybody in here still struggling with domain and range? Be honest. We're all good with it? Find the bottom, find the top. Okay, anybody need to go through that again? Okay, again, I write it out like this all the time. You may want to write it out like this. You like that better? That's okay too. That's just your lowest to your highest. Okay, that's another way to write it. I just like this better. Okay, the equation of the midline. The equation of the midline is y equals the halfway mark between -4 and 8. What is halfway between -4 and 8? 2. The other way to find midline. 8 add -4. What's 8 add -4? 4. What's 4 divided by 2? So the midline for this particular graph is y equals 2. So write that down. That's your midline. Now, I personally would draw the midline in there right now. Draw the midline in there right now. So draw a line at y equals 2 right through there. Okay? Now, that's the reason I do that is because now I can easily look at the midline and say, what's the amplitude? Go from the midline to the maximum point. What's that distance? 6. The amplitude for that graph is 6. It's the distance from the midline to your maximum value. The distance from your midline to your maximum value. That's the easy part. So 2 is my midline, 8 is my maximum. The distance is 6. That's it. One last thing. We need to find the period of the graph. When or how long does it take to repeat? I personally think the easiest thing to do is look at 2 of the maximum values and tell me the distance between them. So the first maximum value occurs at what value? This one's a little bit harder to see on this graph, but let's try it anyways. 135? No. Okay, but look at your grid. What does each mark on the X equal? No.
60.
Yeah. 60, 120, 180. Okay? So each mark on there, because 180 is the third mark. You agree? 180 is the third mark on there. So then there's 2 marks before that. So I take 180 divided by 3. Each mark represents 60. So where does the first maximum value occur at? 120. Right on. 120 degrees. Where does it hit the second highest mark? 360. So I take 360 degrees, subtract 120 degrees. What does that equal? My period for that graph is 240 degrees. The period is how long does it take for it to repeat itself? In that case, I just go maximum to maximum, and it makes it the simplest. Okay? All right, I took a lot of time. There's a lot there. But it's going to make tomorrow easier when we go through this, the graphing part, because I'm just going to be reviewing it and not teaching it to you new. Get through the first 8.1 and 8.2 for tomorrow. Again, I think there's 5 in here, right? 8.4, 8.5. Yeah. So that gives us to the end of the week to finish this whole thing. So let's do 8.1 and 8.2 for tomorrow. Then we'll work the 8.3 and 8.4, and then 8.5 is going to need a day and a half itself. Okay?